Good afternoon, everyone, and welcome to today's webinar, Unified Network Observability for Any Network. My name is Mai Zidane from MBCom Marketing Team, and I'm delighted to be your host for today. Just before we begin, just a quick updates. Please keep your microphone muted during the session and use the chat box to share any questions. We will be having dedicated time at the end for the Q&A. It's my pleasure to introduce our speaker today, Prem Prakash, our sales engineer at MBCom. Prem will walk us through today's topic. Please join me in welcoming Prem.
Thank you so much. Hi, good morning, good afternoon, good evening, everyone. My name is Prem Prakash, and I work as a pre-sales consultant for MBCom, managing Broadcom Network Solution. So we will go through today's topic, that is network observability from Broadcom. So quickly share my screen. Okay, so today we'll be talking about unified network observability for any network from Broadcom. And as I said, my name is Prem Prakash, and I work as a senior pre-sales consultant in MBCom with more than 14 years experience in network and infrastructure monitoring solution. So let's talk about today's challenges that we have in network operations, right? So we all know that in initial days, we used to have data centers and remote offices, which is connected using MPLS or point-to-point link, which we call it as managed network. And now we all see that we are adopting to cloud and SaaS applications. And at the same time, after pandemic, we have seen users working from home, working from remote locations. And this traffic goes through unmanaged network, that is from your ISP network. And also we have seen people are adopting SD-WAN. Adopting this kind of technologies makes it more complex because the SD-WAN vendor or monitoring solutions provide too many alarms, and also they offer edge-to-edge monitoring only. And also we have seen people are adopting SaaS applications like Microsoft Teams or Office 365. And when we have this kind of applications, we have network blind spots. And we have work from home users where we do not have any visibility on what network they are connected to. And also we have a zero trust or SASE being implemented at many customers where we have no visibility when the traffic is flowing through cloud proxy. So when we have a complex environment like this, it is very challenging for traditional monitoring solution to monitor this kind of network. So Broadcom Network Observability is a solution which can monitor each and every piece which was listed above with respect to faults, performance, and also topology. We can talk also about scale. Broadcom can scale up to 300,000 devices, and it can monitor up to 6 million interfaces. We can also talk about modern networks, software-defined data center, software-defined WAN, which can also be monitored using Broadcom Network Monitoring Solution. Okay, to paint it, so what we do, Broadcom Network Monitoring Solution can identify faults, it can throw alarms for you, it can also get performance and flow reports. We can draw end-to-end topology, the network topology of your physical network and also your virtual network. We can capture configurations, syslogs, we can monitor SD-WANs, and also we can do end-user monitoring. So this is what Broadcom Network Monitoring Solution offers. So these are different functionalities within NetOps that we have that can do monitoring for you. So let's talk about each and every feature or each and every module. Let's talk about first fault management module. Fault management module is used for discovering your layer 2 and layer 3 devices. So we are vendor agnostic. We support any vendors. It can be Cisco, Juniper, Palo Alto, Fortinet, etc. The fault engine is capable to capture configurations and also identify if there's any changes in the configuration, which can be alerted to the administrator. And you can also quickly revert back to the previous configuration. The system has patented algorithm using which it can do root cause analysis and identify the root cause alarm and the symptom alarms. You can also create business services on network level where you can see the impact of your service if there is any network degradation. Let's go and talk about performance analytics. Performance analytics module is used to collect performance data from SNMP and non-SNMP devices. So when I say non-SNMP devices, think about ISP device or telco devices where SNMP is not providing much information. This performance data or performance metrics are saved in the database, which can be used to run your trend reports, or if you can run projections or capacity planning reports to understand how your metrics are performing. Like example, your interface utilization or bandwidth utilization is performing and how it is going to perform in near future. So this kind of projections can also be done using performance analytics engine. Next comes the flow engine. If your interest is collecting net flow to understand the bandwidth utilization and also to understand what kind of applications or traffic is flowing through your interfaces. You can also use NetFlow to understand the top talkers, which user is consuming more bandwidth and what applications are being used most. So this can help you out in understanding your usage, and also you can plan for future growth. The fourth one talks about virtual network assurance. So when we have technologies like software-defined network or software-defined WAN, our virtual network assurance can be used to discover this kind of modern networks and also provide topology view, and also it can connect with your physical network. It can do root cause analysis across physical and your virtual network. We can have the same visibility related to faults and also performance as we see in for the physical network environment. The fifth engine, the last one, so this is provided using AppNeta. So AppNeta is a solution which was acquired by Broadcom, and it has been integrated with the network monitoring solution. So this AppNeta is going to provide you end-to-end visibility, that is hop by hop analysis. It can also help you out in sending synthetic traffic to understand the performance of your application and also your unmanaged network. This can also identify traffic that is flowing to your network using span traffic. To see the key capabilities, we can see the faults, we can see the end-to-end topology of your network, and we can see the faults attached to that. And we can see performance metrics. We can immediately see performance metrics, and we can see the flow metrics to understand what traffic is flowing through, to identify the source, the destination, and what is the protocol that is running in your network. And we can also see the SD-WAN environment or SD-WAN tunnels, how the status of each and every tunnel is, and it can be displayed in topology. We can do configuration captures, and we can also revert back to the previous configuration if there is any issues, and also it can be used to check compliance. We can use NetOps to also see network experience, to understand how the user experience is when you're accessing a cloud or a SaaS application. So let's talk about active experience. So this is something new which is added within the network monitoring solution existing. So what is active experience? So the customers who are using DX NetOps, now Broadcom has given privilege for them to use and test the active experience which is provided using AppNeta. They can use their existing component within the DX NetOps, that is data collector, and they can convert that to be a monitoring point from there where they can do active testing to their cloud application and to their ISP networks. So this is where you will be filling the form. This is for the existing customers. If existing NetOps customers are interested in using Active Experience, or if they want to try this, from the NetOps console, you can go to this page and you can register yourself, where .com provides you 3 universal license where you can test AppNeta use cases, and also you can use to understand performance challenges on your unmanaged network and application. So AppNeta does monitoring in 4 dimensions. So first is network path. So it sends test traffic from source to destination. It understands what path the test traffic is taking from the source to the destination. So it can draw a path of hop by hop, and it can understand which hop is taking longer to respond. It can also do web URL monitoring. So you can monitor any web URL or HTTP URL, and we can run synthetic transactions, and we can send test traffics on the network or to the application, and we can see the visibility of how the application performance is. So it can be any application in-house, or it can be any SaaS application. So there is also passive monitoring in AppNeta, where we can use span traffic or mirror traffic to understand what kind of traffic is flowing through your network. So it can also tell you which users are consuming more bandwidth, and it can monitor and identify up to 2,000 applications out of the box. For example, if you want to see a user, if you want to see an application like YouTube or Netflix or Facebook or anything, right? You can have automatically visibility, and you can understand which users are consuming or using this kind of applications. Since we have the span traffic, it can also be used for packet captures. So you don't have to run Wireshark or TCP dump when you want to troubleshoot some issues, right? So we can use the existing solution within NetOps to download packets based on your filters, and that can be forwarded to the respective team who can use that for troubleshooting purpose. And what is the value that AppNeta provides? So using AppNeta, we can monitor the usage, we can monitor the experience of accessing any application URL, or it can be HTTP API URL, and we can also see the delivery path, the hop by hop view. Using this, we can, the use cases here are, if you're doing some transformation, for example, if you're moving your applications from on-prem to cloud, and you want to validate if this transformation is successful or not. So you can do active testing using AppNeta to your on-prem application, and at the same time, you can do it for your cloud application. And you can see and compare the performance, how the user experiences when they're accessing the on-prem application and when they're accessing the cloud application. You can validate, and then you can understand if everything goes good, you can move the application. You can move it to the production. It can also help you out in reducing noise, right? Where if there is any user experience, you know where the problem is coming from. We'll not be chasing multiple teams here. For instance, if there is an issue with Microsoft Teams, so the first person to blame is the network. So you know from AppNeta if this problem is coming from your network or it is coming from Microsoft Teams server. If it is network, is it belonging to your network? Because of this, there is less number of tickets because AppNeta is going to proactively monitor your network and applications, less number of tickets, and it makes your IT more efficient. Your IT can spend more time working on other complex issues than chasing multiple problems. And also it helps you out in providing visibility for work from home users. So how this is done, how we are doing the testing. So the testing is done using a component called monitoring point within AppNeta. So the monitoring point has different flavors. So it can be implemented as hardware. So we have different sizes for hardware. So we have data center hardware, which is capable of monitoring up to 100 Gbps. And we have small office, large office. And also we can implement monitoring point on as a VM in VMware or KVM environment. It can also be enabled on Cisco 9K Arista and Juniper devices. And for work from home users, we can use or install an agent on Windows or Mac operating system. If you want to monitor from any cloud environment, we can deploy a container in cloud, for example, in AWS or Azure or GCP, from where you can monitor, you can start monitoring from that specific location. What is network path? So network path is the path, logical path or logical route that a packet takes when it starts from the source to destination. AppNeta is going to trace this path from source to destination, and it can see if there is any changes on the routes or any other details within the network. Using AppNeta, you can gain visibility not only inside your network, but also beyond your data center. So you can see what are the networks that is part of your environment, like branch office or data center. And then you can see, have the visibility on the hops that is on the ISP end. And also you can see the hop and performance of the network that is owned by your cloud or enterprise vendor. So we can also monitor your applications as we spoke about Microsoft Teams or Office 365, where we have no possibility to implement agents, or we do not have the regular SNMP enabled, or we cannot implement application agents on top of this kind of SaaS or cloud applications. So using AppNeta, we can send synthetic traffic to the application, and also we can monitor how the application performance is. And you can understand if this problem, if it's coming from a single location or if it is coming from a multiple location. We can see how much time it took to reach the homepage of Microsoft Teams. And also we can see how much time it took to log in and to start a meeting in Microsoft Teams as an example. We can also see on the end user's perspective to understand how much time the network took to respond, how much time the server took to respond, and how much time the browser took to respond. So AppNeta can also be used when you want to validate, when you're using cloud, enterprise cloud from Symantec or from any other vendor, right, like cloud proxy. So in that case, if there is any challenges, if there is any performance bottlenecks, when the traffic is flowing through the cloud proxy, so we do not have visibility for this kind of traffic. And if there is any outages, you do not have a solid proof to prove if it is coming, if the problem is from the cloud proxy, or if it is from your ISP, or is it from the remote application vendor. Using Broadcom AppNeta, that is experience monitoring, you can send synthetic traffics from your network or from remote user network, where we can see what hops or what route the user traffic, the test traffic is taking through. So you can also see how much time it took for you to reach from your office from your home to the WSS ingress on your cloud proxy. So this can give you an idea if there is a delay that is happening in your network, or is there a delay that is happening till when you're reaching the WSS ingress, or if there is a delay that is happening inside the WSS or the cloud proxy. So for work from home users, we can have the visibility of each and every hop from the source to destination. And additionally, we can understand what kind of network the user is using. So the AppNet monitoring point agent on the laptop can understand if the user is connected using wired or wireless network. It can also gain visibility in the performance of the wired or wireless network, how the performance is, what is the signal strength, and it can also see what is the retransmit time. And it can see also how many stations are connected to that Wi-Fi network. And it can also get visibility into the host performance, how the CPU memory utilization is on that specific PC, because this is something which can also contribute load or performance issues. So this is the monitoring that any traditional monitoring solution can offer you. Using SNMP, using non-SNMP, using REST APIs, ICMP, we can monitor this kind of technologies like home office, data centers, devices in data centers. What AppNeta is providing or adding value is monitoring or giving visibility to unmanaged network, that is to your ISP network. So now Broadcom has combined the traditional network monitoring solution NetOps along with AppNeta, and we call it as Network Observability, where we can provide end-to-end visibility, whatever network it is MPLS, it is ISP, if it is point-to-point, VPN. So any network observability from Broadcom can provide visibility, and also it can provide you end-user experience. This is an example just to show you how the actual networks look like. So how your offices are connected using internet, using MPLS, and also when SD-WAN is in place, you have multiple tunnels configured. You can understand how your underlay network and overlay network is performing using active testing from AppNeta. So this is from our fault engine called Spectrum within NetOps. So Spectrum is Broadcom's monitoring solution, and it is there in market for more than 20 years now. So it had patented algorithm inside it, using which it can understand, it can do root cause analysis. In this example, if there is a complete network failure, for instance, if the upstream device is down, and due to which all the downstream devices are not reachable. So Spectrum Intelligence can automatically trigger alert on the upstream device. It understands where the problem is, and it will suppress all the downstream alarms. So in this case, you will be seeing only one alarm, and the network team will be chasing that specific alarm instead of going and troubleshooting or reaching all the other network components. So this is done using the patent algorithm out of the box. So there is a new topology introduced within NetOps, where you can have more detailed visualization about your topology, and also you can instantly understand alarms on that specific network component, and also quickly draw performance charts. And this performance charts can be used for trend analysis. For instance, if you see an interface alarm, you can quickly understand the trend for, let's say, for example, last 24 hours, to see when this trend has reached above the threshold. It can also help you visualize your SD-WAN environment. It can provide you with the details of each and every SD-WAN tunnel, and also it can tell you the status of each and every SD-WAN tunnel. So you can have a connection between your existing physical environment and also to your virtual environment as well in one place. Using app data and NetOps together, so you can do active testing end to end, and also you can measure and compare the underlay and overlay performance of your network. So we are continuously sending test traffic from the source to destination, and you can see the hop view, and also you can drill further to understand each and every hops in the network and also the SD-WAN tunnels that you're using in the network. So this example shows you how you're going to troubleshoot if there is an alarm. For suppose if there is any alarm with respect to network path change, or if it is with respect to utilization issues, performance issues. So you can understand the status of each and every SD-WAN tunnel. We can have a visualization of what tunnel is performing good, what tunnel is performing bad. And at the same time, you can see the capacity, end-to-end capacity, and also other metrics like data loss, data jitter, and also the voice MOS values if you're interested in voice traffic. We can also have a time bar view to understand at which particular time this threshold was breached. And also we can have the hop by hop view from the source to destination. So you can understand when there is any issues, you can go up to the hop level to identify where that problem is coming from. And at the same time, you can also see the end-to-end capacity if it is because of the capacity issues. If it is issues with capacity, if your bandwidth is utilized, you can quickly view what traffic is flowing through your network. So which host is consuming more bandwidth. So you can have a visualization about each and every protocol that is running, and also you can have visualization about which host is consuming more bandwidth. And you can also do projections. If you want to do projections to understand how the utilization is, how it is going to be in near future. To troubleshoot more further, you can have this kind of view where you can see each and every hop, and also you can see the data loss, the latency, data jitters, round trip time for each and every hop. So in this case, we can see that hop number 4, there's a data loss of 4.6662%. Next comes the configuration management, right? So NetOps monitoring solution can capture configurations from your network devices. It can be any network device. It can be Cisco, it can be Juniper, it can be Palo Alto. We can capture configurations. If there is any changes, we can alert people, and you can quickly revert back to the previous configuration. Network Configuration Manager can also be used to upload firmware. If you are interested in upgrading your network devices, you can push firmware upgrades on multiple devices at once. And if you are interested in checking compliance, network compliance, to understand or to check if specific lines are present on my network devices or specific lines shouldn't be present on my network devices. So you can run a compliance check using which you can see what are the devices that are compliant and what are the devices that are violating that compliance. So we have introduced syslog integration. So we can capture syslog messages and it can be converted to alarms, because at most of the time, what we have seen is, the traditional SNMP monitoring or SNMP trap does not provide much details, right? So it is good to have syslog messages for troubleshooting purpose to understand more in more detail about what that problem is. We have introduced syslog adapters. If you have existing syslog collectors like Splunk or Elastic, so we have syslog adapter which can link to Splunk and Elastic, and it can get the syslog messages. So we are not getting the messages and storing in the database. So we are collecting it only on request. So that this does not load the NetOps database by collecting and saving all the syslog messages from Splunk and Elastic. So if there is any alarm, for instance, in this case, we see a authentication failure wrap or a server down alarm or a CPU utilization alarm. So any alarm, so you can quickly see the syslog messages which we received from Splunk or Elastic using the Raptor. So this helps us out to triage the issue, to understand what the problem is in more detail, and also using this feature, you don't have to go to a different team who is the admin for Splunk or Elastic to get access to syslog messages. So you have the integration in place and you have this messages already in NetOps console, which can be used for the troubleshooting. Using NetOps solution or Broadcom Network Observability solution, you can also have visibility into your Wi-Fi environment, right? Because we have seen, everyone is using Wi-Fi these days, right? So you need to have a tool that can provide visibility into your wireless environment, and also it can help you out in understanding the performance and challenges, and also to troubleshoot any performance issues within the Wi-Fi network. So you can have performance reports to understand how your Wi-Fi network is performing. Okay, with respect to the controllers, with respect to the access points, how many clients are connected to the access point, what is the, if there is any interference, radio interference, if there is any CPU or memory issues on your access points or controllers, or if there is any latency, within the traffic that is passing through your Wi-Fi network. So all these things related, metrics related to Wi-Fi can be monitored using Broadcom network monitoring solution. So let's talk about market leadership. Okay, so we have GigaOM Radar. So this is another report from GigaOM, where Broadcom network monitoring solution was marked as leader for 5 consecutive years in a row. And also we have another analysis report from EMA, where Broadcom was marked as leader for 2 consecutive years. And we have other vendors like PeerSpot, where even Broadcom network monitoring solution is marked as leader. Let's quickly go to demonstration to understand how these features work on a real environment. So we are seeing the network monitoring solution from Broadcom, where we have NetOps and AppNeta together. And let's go and quickly see a few use cases here. Okay, so this is how the NetOps console looks like. So the default page, sorry. Okay, so this is how the NetOps console looks like. So you'll be able to see all the live alarms in your environment. Okay, it can be from your active experience. It can be from your network devices with respect to interfaces, configuration changes, or any tunnel related alarms. All the faults are seen in one page, and you can use the same page to assign a troubleshooter. If you want to assign it to some specific user, you can click the troubleshooter option and you can assign it to the troubleshooter. And this alarm will be assigned to that specific user. You can also do testing like ping, poll, and also trace route. And if you have integration with ITSM solution out of the box, we have integrations with ServiceNow, Broadcom Service Desk, BMC Remedy. So we have integrations with multiple service desks where you can automatically or manually create tickets for any faults. You can also see the details about each and every fault, what that fault is. And also you can see more details about the interfaces. Okay, if there is any interfaces for this one. And also you can see the neighbor topology. So is this alarm impacting any of my neighbor? You'll be able to quickly identify the neighbor relationship as well. So let's go and see how the topology looks like. So let's go to the topology. So this is the new topology within NetOps that has been introduced. And you can see the complete topology, the global topology, and also you can group the topology based on technologies, or you can have a custom groups as well. Let's go with the SD-WAN topology here. So you can see what are the controllers that are part of this SD-WAN, and also you can see what are the other components that is part of this SD-WAN. I can expand it, and also I can see how are the links. Okay. If I want to go deeper, I can just click on this link and then I can understand what are the tunnels and what is the status of each and every tunnel in my SD-WAN environment. I can quickly click on any of the component and then I can immediately see the performance metrics. Okay, like what is this exactly? What device is this? And also I can see if there is any alarms. And also I can see what are the components, interface components that is present on this device. It can also provide me details with performance metrics. So quickly from the topology, I can view the performance metrics as well for that device. So it can be for device or it can be for interface as well. Sorry. You can also have performance reports. For instance, if you're interested in checking the flow traffic, right? So you can click on the flow traffic to understand what kind of traffic is flowing through. It can provide you a visual representation of what are the device or what is the interfaces and what is the protocols that is consuming more bandwidth. So we can see that this is the SSH traffic, and we can see HTTP traffic. Okay, we can see what is the source and what is the destination, and also the amount of traffic that is being used on HTTP. You can go further in depth inside this to understand more in detail. Okay, and this information is collected using the network traffic to get visibility into your traffic details. We can use NetOps for drawing projections. If you want to understand the current trend and also you want to do projections for future. So NetOps can be used for projections as well. So here we can see how the utilization was in July and in August. And then we can also do projections in September 30 and October 30 and November 30. We can change the time frame if you want to do it on a weekly basis or on a daily basis or on 3 months basis. You can change the time and quickly you'll be seeing that projections happening for every 3 months instead of 1 month. As we can see, we need to change it for 3 months. NetOps can also be used to get the active experience from AppNeta, since we have tight integration between NetOps and AppNeta together. So you can see or visualize the AppNeta related data as well. So AppNeta is, checking the network paths. So you can understand how many paths are good or how many paths are not good, right? You can also see there are a few paths which has more data loss, right? You can click on that and you can quickly see what that path is. And you can quickly drill down to this one to go in depth to understand why this path is having this packet loss or issue. You can also see other metrics when we are doing the network path test. We want to understand the capacity, end-to-end capacity, what is outbound capacity, if there is any capacity challenges, if you want to see latencies, round trip time from the source to destination, you can see that. And also you can understand which network paths are performing very slow. Okay, so there are different dashboards here. You can also have flexibility to create your own dashboard. So the dashboard creations can be done from here. You can edit or you can create your own dashboards. So now let's go and see how the AppNeta experience looks like. Let's go to the AppNeta. So this is how the active experience works. So if you want to test the application performance, how the application performance is, so we can see there are different applications that we are monitoring as of now, and we are monitoring it from different locations. For instance, let's take the Office 365 Outlook. So we are monitoring it from different locations, and we can understand, the availability of that application. You can also see the latency, average transaction time, and all these metrics for different from different locations. And if you want to drill down to any of this test, you can click on that specific link, and you should be able to see in more detail about what that application performance is. So here we have different milestones here. So we're not only checking the entry point of an application, we are logging into the home page using username, password, and then we are creating activities like, for instance, if you want to use Office 365 or office.com, you can log into office.com and you can go to Outlook or you can go to OneDrive. So as a transaction. So you'll be able to see how much time it took for each and every transaction. And you can also change this to end user experience, where you can see how your network responses and how your server responses and how the browser responses. We can also see metrics like redirect time, DNS lookup time, TCP time. So this will help you out to understand the experience, because at times the DNS lookup can take much longer and it can also have performance bottlenecks. So this is also something which is important. So we're collecting DNS response time as well. And also we are collecting DNS responses from all the available DNSs. If you have multiple DNSs configured, you will be able to see the performance of each and every DNS. So this can help you out in prioritizing your DNS and to understand which DNS servers are performing or responding very slow. So let's assume that there is a performance problem at this particular time, right? Let's go back to the milestone. Let's assume that there is a performance problem at this particular time. So now you need to, you want to understand, or you want to gather more proof so that you can take it to Microsoft. So I can click on this specific time frame. Since we are doing the polling for every 15 minutes, we're doing this testing for 15 minutes. So we can see if there is any problem or if there is any error message, the system can automatically take screenshots for you. So it can take screenshot. If it is a 404 error message from Microsoft, you can see that error messages as a screenshot. And also you can see all the backend calls that is happening from your source to destination, source to Microsoft server. So if there is any error messages, if there is any call that is taking a long time, you'll be able to see that which call is taking more time. And overall, we can see how much time we are taking to connect to the Microsoft server, how much time we are waiting for a response to the Microsoft server, right? So let's assume that if your application performance is good, but you feel that the network response time is taking longer time. Let's say, for example, if it's 2.6 seconds. So you can quickly jump to the network path. Okay, you can click on the application delivery, and which will take you to the network path, right? So where you can see how your traffic is flowing from source to destination and what are the different hops that is involved. So you can also see events with respect to violation. So we have thresholds configured here for data loss if it is more than 2%, we have configured thresholds and also for data jitter. If there is any events, you can be able to see it. We are saving this data for 365 days, and you can go back and forth to understand if you want to do it for a longer duration. So now we can see the hop by hop view. You can do it on a hop level or on a network level, or you can go with the hop by hop view. And we are using our patented algorithm called TruePath to get this metrics to see the capacity, available capacity, and utilized capacity. So this is end-to-end capacity. It's not exactly your bandwidth, but it is the capacity from source to destination. So which can also help you out in troubleshooting to understand if the capacity is overutilized, then you will be seeing the data losses or packet losses. You can see data loss. If there is any data loss happening, you'll be able to see it. And also you can see that there is an event at this particular time because of the data loss. We can also have metrics like latency and round trip time if there is any challenges. So we have seen this one. We have seen that there is a data loss. Okay, we have seen that there is network challenges, but we still do not know whether this problem is coming from my own network or it is coming from third-party network. So every time there is a problem, every time there is a violation, AppNeta automatically creates a diagnostics. You can click on the diagnostics and you can see every hop. And if I'm interested in data details, I can click on the data and I can see what are the hop that is involved. And I can see from here, from till here, that I don't see any data loss. The data loss is 0 and the maximum is 0.51. I see a data loss at this particular time, this particular point, that there is 1.37 data loss. So I can understand which hop it is. I can just hover the mouse and I can see this is coming from Comcast. If the data loss is more, right? So I can use this as a proof and I can open a ticket with the ISP Comcast stating that I have a performance issue and I see that it is coming from this specific hop. So this is the kind of proof which AppNeta is going to provide you when we are monitoring or when we are using unmanaged applications like Office 365 or Microsoft Teams, or if you're using ISP networks like Comcast or anything else. The last one is about the usage. So AppNeta can collect the usage traffic. So you can send span traffic from your network devices to AppNeta monitoring point, and it can provide you visibility of what applications are running in your environment. So it can identify 2000 different applications out of the box, and you can also configure custom applications if you have any. So for instance, if I want to understand or see which users are using Yahoo in this case, I can click on that. As of now, I have only one monitoring point from where I'm collecting the span traffic. So I can click on that and I can see the users that are using or application like Yahoo or anything else. For some reason, it's taking a long time, but yeah, this will provide you the visibility into each and every user that is using yahoo.com. Or let me go with another application, like let's say, for example, MS Office. Okay, I believe that there is, it's taking some long time to get this data. Okay, but you will be able to see the visibility into that level as well. Okay, up to the hop level as well, or up to the host level as well. So we have integration, and then all the data from the AppNeta is being sent to NetOps. So NetOps becomes your centralized console for creating dashboards and also for creating alerts or integrating this with the ITSM solution or with the SMS gateways, or you can also integrate with SMTP servers for automatic emails. So here, this completes the demonstration of the network monitoring solution. Okay, so now we have around 5 to 7 minutes. We can leave this for Q&A session. Let me check if there is any questions.
Thank you. Yeah, thank you so much, Prem, for such a great presentation. Yeah, I believe we have a question here sent by John. What's the value of NetOps when customers has ecosystem with a specific vendor that provide their own tools?
Okay, so we're going from top to bottom or bottom to top?
I can see we have two questions only, so feel free to, yeah.
Okay. Okay, so we have, for example, when we talk about specific vendor, we have seen, vendors who offer SD-WAN solutions. So they have their own monitoring solutions, right? But what the challenges what we have in there is there are too many alerts, too many alarms. Okay, and also it provides you visibility from edge to edge network, not from end to end. So Broadcom network monitoring solution or NetOps can monitor from end to end, rather than just edge to edge. And it can help you out in reducing the noise, where we have our own correlation engine, which can correlate multiple alarms and create one meaningful alarm. So the next question, is there now an overlap with NFA and AppNeta regarding flow data? Okay, so these two work differently. NFA works on the flow data, that is net flow data, where you can configure net flows. But AppNeta works on span traffic. So instance, if there is a customer or if there is a place where you cannot enable net flow, or you want to identify applications out of the box, right? So AppNeta can get the span traffic and it can identify 2000 applications out of the box. So you'll be able to see what applications is running.
All right, so Klaus, does that answer your question? All right, we have another question from what is the other key differentiators with other competitors?
Okay, so we have competitors. So when we take NetOps alone without AppNeta, so there are multiple. We have competitors like SolarWinds. Yes, Zabbix is there as open source. PRTG is there as open source, right? So there are multiple monitoring solutions we have competitor. But when we combine AppNeta along with NetOps, when we call it as network observability, right? So this piece of AppNeta is not being done by other vendors, right? So Dynatrace is more into application monitoring level, but they are not into network area. So they cannot provide visibility into your physical network or your SD-WAN network or your virtual network.
Right,
so when we talk about competition, we can combine NetOps with AppNeta and we can take it to the customer.
All right, thank you, Prem. So Mohammed, does that answer your question? All right. We have another question, Prem. Yeah, thank you. Regarding the strong points against, can you see it?
CACT. Yeah. CACT, PRTG, Zabbix. So CACT, PRTG, Zabbix are open source, and Dynatrace, as I said, Dynatrace is more into application monitoring, right? And it does very little network monitoring. But when we talk about NetOps along with AppNeta, it can provide visibility into your physical and also virtual network. So it can provide you insights into your SD-WAN network as well. And it can also help you out in configuration captures, reverting back to previous configuration, right? And when we talk about CACT, PRTG, and Zabbix, so all these are open source, and you need to have more expertise in configuring this, and also feature comparison with NetOps. We have more features when we introduce like SD-WAN environment, or when we introduce like active experience from AppNeta to this kind of competitors.
Okay, great. So I hope, John, that your question is answered now. So how do you do the sizing?
Okay, so sizing for NetOps is done based on number of devices, whereas AppNeta it's based on how many applications or URLs you want to monitor. Okay, so it also depends on from how many locations you want to monitor or do active testing. So based on that, the sizing is done for network observability solution.
So Mohammed, do you have like specific? Yeah.
Yeah, this question is very. I mean, it's not clear. We need more information in understand to provide sizing details. But to make it short, it is based on number of devices and number of endpoints on which you want to do active testing and locations. Yeah, this is a very good question. Yes, network monitoring or NetOps provides you all the features within the license. And it provides, as I said, it provides 3 universal license for active testing or active monitoring. So when I say 3 universal license, so you can implement 3 monitoring points. From each monitoring point, you can test 15 URLs or 15 targets. So it pays like 45 URLs or 45 endpoints. You can do active testing. All the other features, network flow, fall, performance, everything is part of NetOps. So it comes within the same offering.
Great. Thank you so much. All right, so looks like we don't have further questions at the minute. Thank you again, Prem, for the insightful presentation, and thank you all for joining us today. Before you leave, we kindly ask you to complete the short survey you will be having after the session, and the record will be shared with you the soonest. Also, if you would like to like explore further or schedule any demo, please reach out to us at info@mbcom.com. We truly appreciate your time, and we look forward to welcome you on our coming session. Thank you so much, everyone. Have a great day.
Thank you, everyone. Have a nice day.
Thank you.